7.2, solving exponential equations. We're not covering inequalities this year, so you're able to cross that part out. But our goal when we are solving exponential equations is always to look to see if we can rewrite the bases with a common base. Because if the bases are the same, then the exponents can be set equal to each other. Look at number 1 for an example. 3 and 9 can both be rewritten with a common base of 3. That would mean that 3 would just be 3 to the first power, and 9 would be 3 squared. They both have the same base. So we can go back into the equation and replace both 3 and 9 with their common base equivalents. 3 would just be 3 to the first power, which doesn't really change anything. And 9 would be replaced with 3 squared. Now we have these exponents for each of them that we need to go back in and put into the problem. The exponent gets put into parentheses. Now on 3, distributing a 1 isn't going to change anything, but on this side, the 2 definitely matters that we put the rest of it in parentheses. So in our setup, we have 3 on both sides, so they have the same base. That means that I can take the exponents and set them equal to each other. And we want to take not just the exponents from the original problem, but the entire exponent and set it equal to each other. So we will have 1 times x minus 4 equals 2 times x plus 28. Now we can solve this just like a normal equation that we've been doing since Algebra 1. You're going to distribute on both sides. And solve out the rest of the problem. Subtract x from both sides. Subtract 56 from both sides. And we get that x equals negative 60. Now you should be able to check this on your calculator by using the original problem and plugging in what you got for x. Now there is going to be one exception to that rule, and that is if you are getting a problem that is, or a number that is so big that the calculator can't handle it, which we'll see with number 2. But other than that, you should always be able to check it on your calculator. So we have 3 raised to the power of x, which is negative 60, minus 4. And then 9 raised to the power of x, which is negative 60, plus 28. And we get the same number on both sides. That means that we did this problem correctly. Take a look at the next problem. 4 and 64 needs to be rewritten with a common base. Now in this case, we can use 2 different bases. We could have a common base of 4, which would mean that we would have 4 to the first power and 4 to the third power. Or you could have used a common base of 2, in which case 4 would be 2 squared and 64 would be 2 to the 6th power. Either one would work as long as these are equal numbers. So 64 has to equal whatever you're going to replace it with. 4 has to equal whatever you're going to replace it with. So in our problem, we have 4 raised to the, and as we saw over here, putting that 1 doesn't really change anything, so it's up to you whether you want to put the 1 or leave it off. But it's going to equal 4 to the third power. And now we're going to plug in our original exponents. X plus 35. Don't forget your parentheses. X minus 3. The bases are the same, so that means I'm going to set the exponents equal to each other. So this exponent is going to equal this exponent. So I have x plus 35 equals 3 times x minus 3. I need to distribute that 3 across. subtract x from both sides, add 9 to both sides, and then divide by 2. Once again, we should be able to check it on our calculator to make sure that we're getting the right answer. So I have 4 raised to the 22 plus 35, and 64 raised to the 22 minus 3. Same answer on both sides. That means that I did this problem correctly. Let's take a look at what happens when I have a fraction. Now these can still be rewritten with a common base. The difference is when you have a fraction, the exponent is going to be a negative exponent. That's how we are able to create fractions, is with negative exponents. So I want you to focus on the denominator. So in this case I have 4, and then on the other side I have 64. Common base for those, just like we saw in the previous problem, you could use 4 or 2. And in order to create 1/4 from a base of 4, I'm going to need to make that exponent negative. So 4 to the negative 1 would give me 1/4. And again, you can always check this on your calculator as well. So I had 4 raised to the negative 1. That should give me the 0.25 that I needed, or 1/4 if you changed it to a fraction. 64 would be 4 to the 3rd power. So the left side, I'm replacing 1/4 with 4 to the negative 1. The right side, I'm replacing 64 with 4 to the 3rd. And the exponents need to be put into parentheses. 2x plus 2 and x minus 1. So since the bases are the same, the exponents can be set equal to each other. So I have negative 1 times 2x plus 2 equals 3 times x minus 1. Distribute that negative 1 all the way across. That gives me negative 2x minus 2. And distribute the 3 all the way across, giving me 3x minus 3. Now I can add 2x to both sides. Add 2x to both sides gives me 5x. And then add the 3 to the other side. Oops. Gives me 1. Divide by 5 on both sides so that x is equal to 1/5. So let's plug it back in and make sure that we get the right answer. We have 1/4 raised to the, now notice I put the 1/4 in parentheses before I raised it to an exponent. That's very important. 2 times 1/5 plus 2. And then 64 raised to the 1/5 minus 1. Now when you're checking this on your calculator, if you have an older calculator, so that when you put in your exponent, let's say for example our 1/4, and when you put in your exponent you just get a little caret, you need to make sure that you put your entire exponent in parentheses then. So this would look like 1/4 raised to the 2. So notice how I started the parentheses to say I'm going to start an exponent here, times 1/5 plus 2, and then close parentheses. Okay, that's only if you have a calculator that doesn't already make it look like an exponent. Okay, so if it already looks like this, you don't need to put the parentheses, but it's certainly not going to hurt anything. Let's take a look at the next one here. Three and 1/9. A common base for those would be 3. So 3 would just be 3 to the first, and 1/9 we know would be 3 to the negative something. So in order to get 1/9, I would have to raise 3 to not only 2, but to -2. Because 3 squared would give me the 9, and making it negative gives me 1/9. It gives you the reciprocal. So I'm replacing 3 with 3 to the first. I'm replacing 1/9 with 3 to the -2. And now we're going to plug our exponents in parentheses. Since the bases are the same, the exponents can be set equal to each other. So we get 6x minus 2 equals -2 times x plus 1. So that -2 needs to be distributed across. Then I can add 2x to both sides, add 2 to both sides, and divide by 8. So I get 0 for my x value. So when I plug it in, let's check our answer, make sure that it's right. 3 raised to the 6 times 0 minus 2, and then 1/9 raised to the 0 plus 1. Got the same thing on both sides so that I know that I did this problem correctly. For the word problem, they are simply asking, when does this side equal this side? So let's go ahead and write that equation out. 216 to the t plus 18. When does that equal 36 to the 2t plus 8? So in order to solve this problem, we have to have common bases. So I'm going to use CB for common base. And the common base here could be 2, or it could be 6. And I don't expect you to know all of your bases for every single exponent that's given, but you can use your calculator to your advantage, or you may use a factor tree. So I would, if I was using my calculator, I would start with 36. Well, I know that 36 can be written as 6 squared. And I'm sorry, I think I said that 2 would work, and 2 definitely would not work for this one. But I know that 36 can be written as 2 squared. So let me see if I can figure out what 216 is with a base of 2. Or, sorry, with a base of 6. 6 to the third. There's 216. If we were looking for a number bigger, you could keep going. 6 to the fourth, 6 to the fifth, until you got something that equaled what you were trying to get. So my common base is 6. That means that 216, we're using 6 to the third. And 36, we're using 6 squared. So 6 to the third and 6 squared are going to go in respectively. And our exponent is going to be used in parentheses. So since the bases are the same, the exponents can be set equal. So we have 3 times t plus 18 equals 2 times 2t plus 8. Distribute our 3 all the way across. And distribute the 2 as well. Subtract 3t from both sides. Subtract 16 from both sides. So we get that t should be 38. Now when you go to plug this back in, we have 216 raised to the 38 plus 18. We're going to get an overflow on our calculator because that number is far too big for our calculator to comprehend. So there isn't a way for me to check this by plugging it back into the original. the best that you can do for checking purposes would be to double check. Does 6 squared equal 36? Yes. Does 6 cubed equal 216? Yes, it does. And then you could take and plug in the 38 into this part. And if it equals the same on both sides, then your math was correct. Flip it over. We're going to skip the inequalities. And sorry, I accidentally crossed out this part, but we are doing the bottom half here. But you can cross out problem number 3 with the inequalities. So we need to be able to write an exponential function for the graph that passes through these points. Now you may recall that you were given at the front of your packet, and I'll flip over there for you, you were given the y equals a times b to the x. That's important because the a value represents the starting point. It's your y-intercept, or the starting factor. Okay, the b value is what the base is going to be. Now, the reason why I say the a value is so important is because in each of these problems, we were given the y-intercept. That means that automatically we should be able to go through and list what the a value is. A in this case is 5. A here is 8. A is 3/4. Then we are going to figure out what the b value is, because we need to be able to figure out a and we need to be able to figure out b in order to write a function. So b in this case would come from plugging in this for x and this for y. So we have 3,125 in for y. A, we said, was 5. We are looking for b, and x is going to be 4. Now we just have to solve this equation to figure out what b is. So I'm going to divide by 5 on both sides. So 3,125 divided by 5 gives me 625. And in order to get rid of the to the 4th power, I have to take the 4th root of both sides. So the 4th root of 625 is just 5. So when I go to plug in my equation, I have y equals a b to the x. That's my answer. Let's do it again. We decided that a was equal to 8 because that came from my y-intercept. So I'm going to plug in 4 for x, 2,048 for y. So 2,048 equals a, I don't know b, to the x, which is 4. So I'm dividing by 8 on both sides. $256, and I need to find the 4th root to get rid of the raised to the 4th power. And just as a reminder, in case you've forgotten, in order to find the 4th root, we use 4 math option number 5. So the 4th root of 256 is just 4. So that's our b value. A lot of people are tempted to stop here, but remember the question is asking us what is the equation. So we have y equals a b to the x. Let's look at the last one here. 3/4 is what we're plugging in for A, so that means 2 is going in for X, and 36.75 is going in for Y. So I have 36.75 equals A, we don't know B, and raise it to the X power, which is 2. So I'm going to need to divide by 3/4. Alternatively, you could multiply by 4 on both sides and then divide by 3. It's really up to you. But either way, we have 36.75 divided by 3/4 gives us 49. So in order to get rid of a square, we have to square root. So B is equal to 7. Now I know that typically when we have taken an even root, we had to put plus or minus. That is not the case when you're trying to find the B value for an exponential function. We are dealing only with the principal roots, meaning the positive ones. So we have Y equals A times our B value raised to the X value. Remember, every equation should have an X and a Y. You just need to find values for A and B. Finally, we have our compound interest problem. It gives us an equation here where A is the amount in the account after T years, P is the principal amount, R is the annual interest rate, and N is the number of compounding periods each year. So then the information given, they give us 2.25%. That would be our rate. And remember, whenever you have a percent, you need to change it into a decimal. So that changes to 0.0225. We cannot put a percent into our equation. And then it is compounded bi-weekly. So the number of times a year that it is compounded would be bi-weekly every other week. So that's 26 times a year. The next value they gave us is you deposited $500. That's the initial amount. That's your principal. What will be the balance? That's A. And that's what we're looking for. Now, recommendation would be to write these variables down every single time from the beginning and then fill them in from the problem. So we are looking for what is A if I plug in 500 for P, 0.0225 in for R, 26 in for N, and then we forgot T over here. It said after 6 years. So 6 in for T. And you can toss that all into your calculator, or you can follow order of operations by hand. Let's see if I can get it without a glare here. So we have 500 times 1 plus 0.0225 divided by 26, raised to the 26 times 6. So that is $572.23.